Okay, let's get started. I'm Colette Sizer, and I'm a coordinator for the CFREE working group in Lincoln. But I want to start by thanking everybody for attending this evening. It's always great to see so much interest in energy efficiency. This is the third presentation given by CFREE. This is our Getting to Zero series. The presentation today is going to be given by Larry Chretien on heat pump water heaters, and he's the executive director of the Green Energy Consumers Alliance. But before we get started with that, I just want to take a minute to, well, let's see, there we go, to introduce you to CFREE. CFREE stands for Carbon-Free Residential, Everything Electric, and we are a working group for the Green Energy Committee in Lincoln. We meet every other week for an hour or so to keep our list of activities organized, and we have great discussions on best practices for being energy efficient. We serve as a community resource for those who are interested to alter their lifestyle, whether you want to retrofit your homes or buy electric cars, reduce the carbon footprint of your eating habits or your travel. Where we aren't the resource, we try to connect you with resources. On the screen is a list of the presentations that we gave last year. And FYI, these are posted on our website, lincolngreenenergy.org, for you to listen to anytime you're interested. And this is our list for this year. We're still working on some of our presentations. Larry gave a presentation on state and federal incentives on the 16th. We had a wonderful presentation by Jay Turner on March 6th. He talked about retrofitting his old house. And today we're talking about heat pump water heaters. We've got another presentation coming up on the 29th on heat pumps again, ERVs, hot water, and more by Ance Hartman. And on June 6th, we're going to talk about how you can reduce your carbon footprint by making better food choices. We have a few others that are in the works that keep track of us, and the dates for those will be announced coming up. So today we're going to talk about heat pump water heaters, and Larry Chretien is going to be presenting for us. And also Michael Moodie. Michael is, maybe Michael is showing on your screen. Michael is one of our active members, and he's become an expert on our team for how to retrofit a home. I think he's done everything on his house that could be done to make a deck house as close to net zero as possible. He's done a tremendous amount of research on heat pump water heaters and installed one in his own home several years ago. So he will be also involved in the question and answer at the end. Michael, would you like to introduce Larry?
Oh, just to say that I really enjoyed his presentation in January about all the incentives and some of the things that I put in that my research showed in preparing for this one turned out to be a little overly optimistic in one area, and he pointed those out to me today. So he's got a good handle on things going on in the state in lots of different ways. But yeah, and we worked well together putting this together, and I'm looking forward to hearing it live now after seeing it on paper. So off you go, Larry.
Well, thank you very much. I did enjoy very much talking to all of you in January, and Michael was correct when he suggested that we do something on heat pump water heaters. Often overlooked. There's so many different ways that we can reduce our carbon footprint, and so we're thrilled to be doing this. I'm going to share my screen now. You can all see that, I think, right?
Yeah.
All right, so here we go. Green Energy Consumers Alliance. We are a nonprofit organization based in Boston and Providence, serving Massachusetts and Rhode Island. And our mission is to empower consumers and communities to speed a just transition to a zero carbon future. We do it through a variety of programs that consumers can tap into. a lot of consumer education, like tonight, and we advocate for better state policies. We work the state houses of Boston and Providence. And so tonight we're going to talk about heat pump water heaters. As some of us were talking about before we went live, everyone's got a hot water heater. Everyone needs hot water. So what is a heat pump water heater? It's like it works scientifically like a refrigerator or an air conditioner to move heat around. So it takes heat from the room that it's located in, and it transfers it to the water in your hot water tank. And it's electric, but it's not the old electric resistance heat that we've all seen in our lives. It's 3 times more efficient, and 3 times more efficient than gas water heaters, almost 4 times more efficient than gas water heaters. So it's a game changer in that respect. Now the upfront cost is higher for a heat pump water heater than for gas hot water for the installation of the equipment. But that's before incentives. We'll talk about the incentives tonight, which help level the playing field quite a bit. And then there are savings on the cost of energy. And we'll talk about that. Now, if you take many showers in a row, for example, there is a chance that the system might need some electric resistance to keep the water hot. It doesn't happen a lot. It depends on how many people are taking showers, if you've got guests and all that, but and whether or not how large the tank is sized for. So there is the predominant thing on the market these days is called a hybrid hot water heater, meaning it's got some electric resistance as backup, but it runs almost entirely on the heat pump. Under normal usage, you would not expect to use the electric resistance much, if at all. And in most cases with a heat pump water heater, if the temperature in the room falls below 37 degrees, it's going to switch to electric resistance. Now that's pretty cold in a basement or wherever, so we don't really expect that to happen. Particularly because you're going to have the heating. In most cases, you're going to have the heat pump water heater located near your heating system that's going to give off some heat as well. Now here's a picture. It's not my heat pump water heater, but on the left, that's one in real life. And you can see there's a blue decal on the middle. It indicates it's an Energy Star rated heat pump. On the right is a diagram explaining what all the parts are. At the top, in most cases, that's where the compressor is that's going to do the magic like an air conditioner or a refrigerator does. And then there's the tank below. I got to give you a big disclaimer. I am not a plumber. I am not an engineer. And so I'm not an electrician. What I'm going to try to explain to you all is why you should think about a heat pump water heater and what the incentives are and what the economics are. Those are the things I like to think I know about. So here's the why. How much energy is used to heat water? So every 5 years, the U.S. Department of Energy does a residential energy consumption survey. And so what this shows, the 2015 one, and I didn't see the same kind of graph for 2020, but basically on average back in 2015 and also 2020, water heating uses 18% of residential energy use. I think you might be surprised at that. It's above air conditioning. This is a national average, okay? Where it's really hot, air conditioning might be higher, and where it's really cold, the space heating is going to be a higher percentage as well. But if you look, you can see water heating comes in second to space heating, significantly higher than things have changed. 100 years ago, the refrigerator would have been a big issue, right? And that's gotten tamed over the years. So this is an important statistic. To go a step further with it, so what's the climate impact of heating water with natural gas, which we should be calling methane, because that's what it is. The average home has a carbon footprint of 15 million BTUs per household per year. And as again, that's 18% of your, this is for natural gas, sorry, for hot water, 18% of your total usage. The typical home in the United States that has gas will have 88.7 million BTUs. And then, so again, look at this, how it, space heating is 45. It's 3 times the amount of hot water, but it's still, then it drops off dramatically to air conditioning, to refrigeration, and so a lot of other small uses like lights and cooking. So, heat pump water heaters are trying to address the number 2 source. And now, so what does 15 million BTUs of methane mean? It's almost a ton of carbon dioxide per year. Again, it's a third of space heating. I think you'd all immediately think that burning fossil fuels to keep yourself warm is going to contribute to climate change. Well, so same with hot water. And so that's equivalent to about 90 gallons of gasoline. Now, these numbers I'm showing you are national averages in that 0.8 metric tons of carbon dioxide per year. Seems a little low to me. I think a lot of us who have a single family home would, particularly if you've got more than a couple of people in the home, you might have a higher amount of hot water usage and therefore a higher carbon impact as well. Now, what we measure here is what goes up the stack, so to speak, when you've got natural gas. What goes up the stack, it's even more carbon intensive when you're talking about propane or heating oil. So the numbers grow even further. What this does not count, and it should, is how much methane is leaked at the drill site and along the transportation corridors before it gets to the house. So if that was measured, we might be looking at a significantly higher amount of carbon dioxide or CH4 methane greenhouse gas equivalent over the course of a year. So why should we switch to a heat pump water heater, also HPWH? So we need to electrify everything in our home: space heating, water heating, cooking, and clothes drying. I already said it's equivalent to 1/3 of space heating, so we need to do that. And I think what you all know is that the electricity supply keeps getting cleaner every day. We keep adding renewable energy by law. A lot of you on this call are from Lincoln or from other communities I know that have municipal aggregation that includes more renewable energy than required by law. And so because of those programs, the electricity supply that we get is getting cleaner every day. So anything that runs on electricity, whether it's these appliances or a car, you're getting a cleaner result. 10 years from now, it's going to be much cleaner even than it is today. Whereas if you've got a gas hot water system, the entire life of that system, it's going to have a bigger impact on the climate. The operating cost of a heat pump water heater are very low. Federal tax credits and utility rebates make the net cost of installation affordable. I would compare that to hot water by gas, oil, propane, or electric resistance. And then I would compare it to heat pumps for space heating. We all need to go to heat pumps for space heating, but it's a bigger challenge. It's a little harder with some home configurations, including mine. My family will do that eventually. But I live in a Cape with it's not an open floor plan. We have forced hot water. It's kind of complicated. So we've got an electric car, we've got an electric clothes dryer, we're going to get an induction stove, but we recently installed a heat pump water heater, and that was as simple as all those other things. It's a lot simpler than space heating in our particular case. And so what we're encouraging, we all want to get to zero emissions as fast as we can, but the order in which we do these things can differ from home to home, right? Now, water heaters need replacement every 10 to 15 years. Mine was well over 10. And so I wanted to take advantage of the Inflation Reduction Act tax credit. So we replaced it in December. And you can plan ahead. You don't need to run out today and get a heat pump water heater, but you know, you certainly want to perhaps replace your old hot water tank before it leaks. And when you install a heat pump water heater, just like when you switch to a heat pump for space heating or an induction stove for cooking or the electric clothes dryer, anytime you're reducing what you're burning in the house, you're going to benefit in terms of indoor air quality. You might improve your respiratory situation. We strongly recommend in both Massachusetts and Rhode Island where we work, there are new programs. Mass Save, I don't know if you're aware of this, but they just recently started up a decarbonization consultation program. You can go to their website and you can schedule a virtual discussion with somebody who will explain to you how you might be able to work out a plan for your home to get to net zero. The state of Rhode Island has a program very similar called Clean Heat Rhode Island. So I'm suggesting that heat pump water heater should be moved up on your list of things to do, but maybe you are a candidate for space heating for heat pumps. Maybe that should go first. Work it out with Mass Save. They'll also explain to you the rebates and so forth that they do. And you certainly want to make sure they insulate the home as well as you can. So there are other opportunities there. And we'll talk for a minute. The Efficiency Maine has a very good website where they have a calculator that you want to look at that shows you how much you'll spend on energy just to heat the water over the course of a year. Assumptions that we're going to talk about are going to vary a lot. Okay, we're focused on Massachusetts and Rhode Island here. We're not talking about what it might cost in Washington State or Texas, where it's warmer and where electricity rates might be lower. So what I can tell you is nationally, you're going to find websites that say that we typically use 50 to 75 gallons of hot water a day. You may have more or less at your house, just remember that. Electricity rates are going to vary. National Grid and Eversource have what's called basic service, which is if you don't choose your electricity supplier, they will provide it for you. And if you look at the electricity supply plus the cost of delivery, those two things, in both cases right now, they match up at 34 cents a kilowatt hour. Unfortunately, that's one of the higher numbers in the country. Now that's going to be in place until July 31st, 2024. Then they will switch their schedule to a new price, but we won't know that new price probably until about Memorial Day. Municipal aggregation tends to be less. And we did a report, if you can go to our website, where we show how oftentimes municipal aggregation has more renewable energy than required by law and is less than National Grid or Eversource. Now, a lot of people are opting for 100% renewable energy. That tends to be a bit higher than basic service, but it's still generally an affordable price. I don't know if there's anyone here who lives in a community that's served by a municipal utility. Their rates tend to be less. That's about 40 cities and towns in the state. The system efficiency, your current efficiency of a hot water system might vary, and what you might get will be different. The system efficiency can vary in my house. Right in the winter, it's taking colder water into the system, and it's going to take a little bit more energy to get the water warm than it will in July. Fossil fuel prices are going to vary a lot. We should think about what assumptions we're going to use for that. Installation costs are going to vary a lot. A lot might depend upon the complexity of your situation. And, let's face it, cost of contractors for anything in Eastern Massachusetts particularly is pretty high. But that can be the case with almost any kind of heating and ventilation and air conditioning equipment, not just heat pump water heaters. Tax credits are important. State and utility rebates will be important. And again, what you assume that a price per kilowatt hour or a price of a therm of gas or a gallon of oil or propane, all those things you can look at this calculator by Efficiency Maine, and you can look at that. I recommend that you go to that website. And so here's what they're showing. You'd be surprised at how many people in Massachusetts still have heat their hot water with electric resistance. In the house I grew up in, that's what we had for a while. And that is by far the most expensive way to heat your water. So you don't want to do that. If you've got one, you really ought to be looking at a heat pump water heater. Look at so that's on the far right of the bar chart. Moving to my left, the propane is still very expensive. An oil boiler is a little bit less expensive. And then the natural gas storage tank is, according to these numbers, it's $303 a year to heat. A heat pump water heater, according to this chart, is $273 a year to heat water with a heat pump. And a natural gas instantaneous water heater, which comes on essentially delivering you, doesn't keep the water hot all the time, but it's there when you need it. That comes in just here below a heat pump water heater. But again, look at the cost of the heat pump water heater is very competitive with a natural gas instantaneous water heater. And, one's got a lot more carbon emissions than the other. Here's what how you produce that chart. You can plug in different assumptions. So you can see I plugged in 34 cents per kilowatt hour for the electricity. Then the dollar per therm is $1.91. You can look at your gas bill if you have gas. That can vary. Then the price of oil is, I didn't change what they had in their system. It was $3.93. It's a little bit, the average is a little bit higher right now. But I want you to focus on the energy factor column. So the heat pump water heater has the EPA now and the DOE have a metric called uniform energy factor, UEF, for a heat pump for water, anything that makes water hot. Heat pump water heater is typical. The one I just bought is 3.88. A natural gas instantaneous tank is natural gas instantaneous water heater is only 0.9, meaning you lose 10% of what you gain of what you're putting in. It drops a lot with a natural gas storage tank or oil as well, and so it's only 0.67. And the electric tank, the resistance kind, is 0.945. So as you can see, the heat pump water heater is using energy 3 to 4 times more efficiently than the other devices. This is the game changer. This is what we're talking about. So this is what makes going carbon free possible. There are rebates available in Massachusetts and Rhode Island. Go to the Mass Save website and you will see them. They've got a great section on water heaters. The state of Rhode Island does as well. I don't know if there's anyone here from Rhode Island tonight. But be forewarned, by August of 2024, if you want an efficient water heater, you will not be able to get a rebate from Mass Save if it's a efficient gas system. Our organization and many others have been suggesting that they should stop giving out rebates for anything that's not electric. So now the rebates that they're gonna, after August 2024, the only rebate you'll get for heating systems or for hot water will be for electric. So I just took this right out. I wanted you to see it. Here's a screenshot from Mass Save's cost example. The average installation cost is $3,200. The Mass Save rebate $750. The federal tax credit is 30%, and the net project cost is $1,715. which makes it very competitive with a gas hot water situation. I'll just say this, I'll get into this, that $3,200 I think is too low for lots of Massachusetts, and I paid higher. My brother paid higher. I got other quotes that were higher, but it's still an affordable project. So a common question people ask, and I gotta give credit. Michael Moodie helped me with prepare for this, but a lot of people are asking, do you need electrical upgrades to put in a heat pump water heater? So I would say first you're gonna ask an electrician that you trust. We're blessed with lots of electricians in Massachusetts. One big question would be, are you going to go with a 120 volt system or a 240 volt system? The 120 volt heat pump water heaters weren't around for a while, but now they're becoming more available. They are marketed primarily in areas where warmer climates, because we're talking about heating water that the incoming water that we're trying to heat up in Massachusetts is a lot colder than most of the country. And so a lot of folks would discourage you from getting a 120 volt heat pump water heater. But I'm seeing in the last couple of weeks, and so preparing for this, there are some being sold, and there are some smart people who are trying them. The 120 volt system can run on 15 amps. And so for most folks, that just wouldn't require any electrical work to speak of, just the hooking it. Actually, you can plug it in, but they're less efficient than a 240 volt heat pump water heater. In order to be eligible for Energy Star ratings and tax credits and rebates from Massachusetts Mass Save, the uniform energy factor must be 2.2 for a 120 volt system, whereas the 240 volt system has to have a UEF of 3.3. So you're getting more efficiency out of the 240 volt system. There's a slower recovery time. So if you had a large family, you may not want to even try the 120 volt system. Another question about whether or not you need an upgrade is, does your home have 100 amp or something more like 200 amps? So I had 100 amp service in the house, but because I've got electric cars, I've got the clothes dryer already electric, and we're going to get the electric induction stove. It just seemed to make sense to go to the 200 amps. So we upgraded to 200 amps. And that's probably what you're going to see. That's what you're going to see in all new construction, newer homes, and all that. So it just seemed sensible for us to do that. There are some good electricians who will show you different ways you can live with 100 amps, even with all these devices. And so I'm not pushing you to upgrade your electrical service. But what's important to know is the Inflation Reduction Act has a tax credit of up to $600 for upgrading your electrical service if you pair it at the same time in the same year with a heat pump or a heat pump water heater. So in December, I had my friend, the electrician, upgrade us to 200 amps, and that set the stage for getting the $600 tax credit because I was also doing the heat pump water heater. And now I can bring in the induction stove, and the wiring's all set for that. Then at a later date, I can do the heat pumps, and the service has been taken care of. You should be aware that what you don't really realize probably with an air conditioner, right? When you run an air conditioner in the summer, it's blowing cool air into your house, but it's also this warm air getting pushed out, but you don't feel that. With a heat pump water heater, it's going to be generally in a room in your house, probably your basement. And as it's running in order to heat up the water, it's going to blow cool air into the room. You wouldn't want to stand in front of the fan that's blowing the cool air, but it's not freezing at all. It's going to drop the temperature. It's going to come out. It's going to drop the temperature of the room by a few degrees. So I had mine installed mid-December, I think. And, when I go down to the laundry room, I don't find it much colder. It has not been a problem. That's been in the winter. In the summer, it's actually going to be a benefit. It's going to blow some cool air into the basement, and you won't even notice it in the summer months. Sorry, the shoulder months. That's like April through June, or September through November. But again, all that can be mitigated if it's next to your heating system. My brother put a thermometer on his heat pump water heater, and to try to see what effect it has on his basement, and it barely moves the needle. It drops, on when it's by a few degrees. So we're not even getting close. We're talking about, I think he said, like, it never went below 60 degrees in his basement, something like that. So we're not talking about potentially freezing pipes or anything like that. On sound, typically you're gonna get a system that goes to 45 or 50 decibels. 50 decibels is as loud as a quiet conversation, or maybe the street if you're in a quiet suburb, maybe a quiet refrigerator. We don't hear it in our basement. And even when we're puttering around in the basement, it just doesn't bother us. What it will create is condensate that needs to be evacuated. So typically there's a condensate pump and a line that goes with it. I had that installed. It goes into a drain in the which, the same drain that the clothes washer does. So that's a minor cost. It's all part of the installation. A heat pump water heater will dehumidify the room it's in, which is usually a good thing. Not majorly so. It's not a dehumidifier, but it has that facet. It does need some space. I've seen estimates from 450 to 1,000 cubic feet, not square feet. So you want to make sure that there's enough room around there for it to get, it can pull air in from the surrounding room. I saw an estimate today, I think U.S. Department of Energy, they went to 750 cubic feet. So just think about that. A good plumber will make sure that it's got enough space around and won't install if you don't have enough. Whenever you buy a heat pump water heater, and I've been saying this forever, whenever you buy any appliance that uses energy, make sure that it has the Energy Star label. That's a program of US EPA and US Department of Energy jointly. And so in order to get the Energy Star label, it's got to be significantly more energy efficient than the average allowed by code. And over the life of an Energy Star product, it's going to be cheaper to run. And they're usually very good products. And they keep changing the requirements for Energy Star. They keep getting more efficient. So some products that are eligible today may not be eligible 5 years from now because of technological advancements and people buying the good products. So there are a number of products you can see at the Energy Star website. They've got an excellent product finder. You can use that product finder for any appliance that you might think of, not just a heat pump water heater. But I would say the 5 ones that you'll find the most: American Standard, A.O. Smith, Bradford White, Rheem and Rude are the same company. That's what I got. There's a Sanko, a split system. It's kind of interesting. You may know somebody, or you may have a mini split heat pump for space heating in your house, where the compressor is outside the house, and they drill a small hole in the wall, and then the actual heat pump is inside the house. Sanko has a product like that for hot water. The compressor's outside, and then the hot water tank is inside. And so it actually takes up less space, gallon for gallon, as one of the other products. But that allows you potentially to get a much bigger tank if you want one. It's not a bad thing for a large family that's going to use a lot of hot water. It's actually more efficient. It's got I believe a higher energy factor, but it's also significantly more expensive than the others. So just, I would say it's probably overkill if you have a small family. So what are the requirements? Again, in order to be eligible for the Energy Star rating, a 240 volt system is 3.3, a 120 volt is 2.2. A gas fired for storage can be Energy Star with only 0.81, instantaneous 0.95. Again, you can look at the criteria at their website. So again, now you're seeing that factor of 4 again. That's important to think about. Here's a video worth watching. I'll send these slides to you all, and you can click on the. You can also Google it. It's a YouTube video that's very well done. And this gentleman, Matt, walks you through what he considers to be the top 7 heat pump water heaters on the market today for residential use. So on the left-hand side, you can see the Senko. The square box is the compressor, and the cylinder, as you can see, it's shorter. That's the cylinder for the Senko hot water tank. All the others are variations of heat pump water heaters that are fully. You can see in all cases the top is the compressor and below is the hot water tank. The video is pretty helpful. Some of you might enjoy learning stuff, and you're going to hear another voice besides mine. You might be inclined to go one way or the other. They're all good products. I have my brother had a Rheem heat pump water heater for over a year before I got mine, and so I was very satisfied. He was satisfied with his, and so that's what I got. But all the others are winners as well. You can learn more. These are some links you really should look at. I mentioned Efficiency Maine has the cost comparison. You should really put this website under your pillow. Rewiringamerica.org has a calculator. They're an organization that helped lobby for the Inflation Reduction Act, but they know as much about it as anybody. All the tax credits and rebates that you can get for going electric. And so they'll walk you through. You put in your zip code, your whether you file jointly or as a single person, whether you own or rent, and your income. It's all anonymous. They won't know who you are. Then from that information, they'll tell you which tax credits and which rebates you might be eligible for. And so they'll actually show you your bank account, if you will, with the Inflation Reduction Act, so that you'll know what incentives you can get. There are rebates in addition to the tax credits that you might be eligible for. There's 2 kinds that both have a component based upon income, and one applies to several electric devices. If you're at 150% of area median income, you can get rebates in addition to the tax credits. The other one, you get a rebate if you can demonstrate that your energy consumption has fallen quite a bit, but there's also an income component to it. Both of those rebates have to flow through the Massachusetts Department of Energy Resources first, and that's going to take some time before we know what the state's how they're going to implement this. And the amount of money, it sounds like a lot, but it's about $145 million for Massachusetts. That's going to go very fast, and so I would say to you, we just don't know the rules, and we don't know how many people are going to partake in it. It's enough to serve a few thousand people in Massachusetts. That compares to what Mass Save spends, which is about $1.5 billion per year. So it's nice to have the federal money, but it's not as significant as Mass Save. The Mass Clean Energy Center has an excellent website called Clean Energy Solutions, and you can drill into what it says about heat pump water heaters. So a lot of the stuff I'm saying to you today, you might be able to pick up. Some people are visual learners, and you might be able to find out more by reading for yourself. And then here's a link to the video that I just showed you a few minutes ago. So you'll have that when you get the slides emailed to you. So here's my story and my family's. We're now my older daughter lives out of the house, so it's my wife and I and a college student who is here in the summer. So we got a Rude 45-gallon, 240-volt system. It cost us $5,200 before we got a 30% tax credit and the Mass Save rebate. Everything you should look for, what's the first hour rating? In the first hour, that should be able to produce 67 gallons. That's an interesting number to get, meaning there's 45 or 50 gallons in the tank, but then it'll be able to produce more with the electric resistance. So we could take 4 showers theoretically in the first hour with that, and then there's a recovery period. The uniform energy factor is 3.88. Here's interesting. The estimated annual usage is 837 kilowatt hours per year, which is about a fourth of what an electric car might use in a year. But this is a national average, the 837. 50 states. Massachusetts, again, because of the water being colder, particularly in the winter, our usage is probably going to be higher than that. When it's running on resistance, if that it pulls 4.5 kilowatts, it uses 21 amps, which is not a ton, which is the other reason why some electricians would say you don't need to have a 200 amp service. It will shift to resistance at 37 degrees or less. It's rated to have less than 50 decibels. It's made in Mexico. Most of the heat pump water heaters that are shown on one of the video that I referred you to are from Mexico. There's one product in South Carolina, I think. There's a 10-year warranty on this tank. And again, notice that the label, it shows, as you can see, almost every product you get now will have an energy label. And it's showing that it's actually off the chart. It says it's going to cost $117 a year compared to what other products are on the market. But it's based upon the national average of 14 cents a kilowatt hour. Again, we're 34 cents a kilowatt hour right now, or at least I am as a National Grid customer. I think you're doing better as Lincoln residents. And here's a fun aspect to the heat pump water heater I got. It is Wi-Fi. It has Wi-Fi on it, so I can actually control it with my telephone. And if you can see the top there, it says DR ready. That's demand response ready. And so it comes with an app for that. What it allows in the future is easy connection to a utility program, so I can shift the usage of the heat pump water heaters off-peak periods. And that's another way to save money. And it's really driving us crazy at Green Energy Consumers Alliance that being able to connect to a utility program, I'm ready to go, my tank's ready to go, but National Grid and Eversource don't have programs where we can take advantage of this technology yet. We're all trying to push them into that direction because we want to encourage off-peak. We want to shift usage from peak periods. 10% of the hours in a year end up costing us all 40% of our electric bill. That's because we have to build the grid to accommodate peak usage, which is happening on the hottest days in the summer and the coldest days in the winter. So this is an example, just like with electric cars, we want to shift time to off-peak periods. And the point is, when we do that, the utility should reimburse the customer because it costs them less to serve you. So we're going to be all over them and on something like this. That's brings me to the end. My organization's a nonprofit. We would appreciate donations, if you will. They're tax deductible. If you give this week, they are doubled because another generous donor has agreed to double donations in the month of March. And you can go to our website to find that page. We have a lot of upcoming events, just like you all do. And you can see those. We're going to be talking about electric cars. Loey Hayes is doing Heat Pumps 101 on April 18th. Next week, a few of us are developing a clean heat standard, which is another policy that we need to drive towards decarbonization in the building sector. That's me, Larry, at greenenergyconsumers.org, if you have any questions. I'm done. Thank you very much.
Excellent, 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 excellent. So any questions from the floor? Anybody, something that's come up? While you're thinking about it, I will say something about the 120 volt water heaters. They when they were developing these, they encountered a lot of the problems that we heard here. That they were kind of slow on recovery, and so they said, okay, well, what can we do to make this system work without using 240 volts? And they came up with the idea of basically what they termed it as something like a heat battery. Rather than heating the water to 120 degrees, which is what you normally set it at around about there, they heat it to 140 or higher, and then they have a mixing valve built into the water heater that mixes it back down to 120. So that 20 degrees difference between 120 and 140 is really amounts to a lot of extra capacity heat that can be transferred into the water when you need it. So in the video that Larry talked about, they describe one of the Ream models that's like that, and it's an 80-gallon unit, and some of them actually go up to 150. But he didn't describe the capacity equivalent of what it would take if you had regular 120 degree water. But it's considerable, and it gets past this limitation of having a less effective, less powerful heat pump than you have with the 240s or 220s.
Yeah, Michael's point is well taken. What I'm also seeing in the market, I've read about them, but I don't know if they're in the stores. But there are companies now selling induction stoves that normally would use 240 volts, and they're making them with 120 volts with a battery attached to it in order to give it a boost, so you can have the induction capabilities. So we'll see if that works over time. It's a relatively new company, but I think the competition between 120 volts and 240 volts is good for consumers no matter what. They're all going to have to sharpen their pencils and technology. I see some questions. Colette, do you want to curate those, or how do you want to manage the questions?
I'm going to leave those with Michael. Are you watching the chat, Michael? I think you are.
Now I am. Question, one of the first ones: what happens with an old water heater? And I guess that's actually could be a very long, complicated discussion about the embodied energy in a water heater, and can it be retrieved? That I don't know, but generally that's it goes out the door with your contractor, and it's hidden from us. Probably shouldn't be, but that's sort of the way it is.
Yeah, Mass Save has a requirement to try to recycle the old one. I don't honestly know how they do that, where it goes, but if you spend some time researching, no one really expects a tank to last more than 10 or 12 years. So I certainly wouldn't recommend, if you've got a hot water tank that's only 5 years old, you might want to wait a few more years and get some life out of it. But if mine was over 10, so I thought, well, I'm going to do this before it leaks, and I think I got my time out of it. So that's
yeah.
Yeah.
So there's a question: what is recovery time? And Loie, who's one of Larry's colleagues at Green Energy Consumers, replied, recovery time is how long it takes to get the water hot again after you've used up all the water, all the hot water.
Exactly.
questions. What's the life cycle of the hot water heat pump? I answered a similar question in the chat. I think the best way to look at that is the standard warranty on non-heat pump water heaters is usually around 6 years, sort of the average as I understand it. Whereas with the the hot water heat pump water heaters, that's about 10 years. So they really have confidence that these are will last a good while. So the next question, well, experience doing this in multifamily and condo. That I don't know anything about. Oh boy, I'm searching my memory. Nothing I can retrieve now. But I don't know, Larry, have you run across that heat pumps in
Increasingly, I think good landlords and property managers are are installing these. These can be installed in larger buildings and that kind of situation, but I'm certainly not an expert at that.
Same here. Karen says that she had an A.O. Smith water heater, failed after a year, was replaced under warranty, replacement failed after 7 months. Third unit has now failed. She doesn't recommend A.O. Smith. Well, I'll give you one more data point. It was my son-in-law and daughter. A.O. Smith failed after a year, replaced. It has now failed. So, yeah, I probably shouldn't say this in public, but anyway, I sort of kind of agree with Karen there. Don't have a lot of evidence on the contrary. Okay, yeah. And then Ethan says they have a Kenmore A.O. Smith heat pump water heater installed 2 years ago. No problems so far. No recommendation. One thing that
if I could, Michael,
yeah.
My research, I didn't come across that. I went with Ream and Rude. It's a fairly common product around here. I do know A.O. Smith is like over 100 years old, and I think they've kept up with technology. So what I'm hearing tonight, is cautionary. But honestly, I've not seen data for any of these that point us to one way or the other.
Right. One thing that I've heard, and I can't remember the source, was that I think it's maybe Hans Hartman, who's going to be doing one of our presentations soon. That if you install your heat pump water heater in the same room as your laundry is done, you have a lot of risk of failure because of the lint that gets into the air. In the video that Larry recommended, Matt Reisinger did talk about the fact that you want to change your filter more often if you're in in the laundry. So that's a possibility. That's true of my daughter and son-in-law. They're in the same room as their laundry, so maybe that's the source of their problems. So,
yeah, and it's also easy to clean the filter. It's not it's not a complicated, expensive thing.
right.
It's a small price to pay to go to zero emissions, I guess.
Yeah. Yep. What do the 10-year warranties cover? That I do not know what the scope of it is.
I'm pretty sure it's all parts.
Think so?
Yep.
Okay. Then Dan Franklin asked about condensate. There are water heaters in a small furnace room, no direct access to a drain. What would they do? And this is the condensate drain that Larry referred to. They're not expensive and they're really easy to put in because it's a very small plastic tube. You just got to snake it through to wherever it needs to go. We've got a couple in our house from our heat pumps, and they just go to a convenient place. Where put the condensate pump in a convenient place, and then it goes to the laundry drain or under the kitchen sink or whatever. Next question, could a gas on demand water heater be retained to use when power goes out? Currently, we switch to battery backup when the grid goes down. Battery probably couldn't power an electric water heater. That is true. That is correct. A battery could not. I did see in something I was reading today that the 120 volt water heaters can be run on a small home generator, whereas you couldn't run a 240 volt one. So that's one option if you had the 120 volts. But could a gas on demand water heater be retained? Go ahead and say.
I'm not sure the gas on demand hot water system would run when the power goes out either.
Yeah. Probably have some electric component in there that's required to make it fire. Basement's around 50 degrees in winter. Will she get good efficiency? I think you're absolutely fine. My daughter and son-in-law's their basement is quite cold, and I don't know, it's quite 50, but I think 50 is plenty good.
I totally agree that when we talk about the energy factor, that's an average of the year. But the efficiency will go down a little bit in the winter. My brother has had his for a long time, and the winter efficiency is just a bit lower because the air temperature and the water temperature are lower than in the summer. But it's not a problem. It's over the course of the year, you're getting your money's worth on that.
Right. Good. Robin Sklar says we presently have electric hot water heaters. Would there be a benefit to go with heat pump water heaters? Absolutely. That is the best trade you'll make. No requirement for electric upgrades, and the cost is going to be, a quarter to a third, something, I don't know, in that range. A lot cheaper.
Yeah, please
Yeah.
do that, and then let me know how much you're saving. I'd love to use
Yeah.
that as an example.
Are heat pump water heaters also expected to last only 10 to 12 years? Well, the ratio, I'm tired of repeating to myself, but I don't have any other data that if most water heaters last 10 years plus, have a warranty for 6 years, because they don't want to warranty it for 10, expecting that it's going to fail at 10 and then have to pay up. So I think you could probably expect the same ratio, something similar, that heat pump water heaters with a warranty of 10 years, they're likely to last 15 or longer. So our old 1850s farmhouse is 100% electric, including EV. Good for that. Fieldstone foundation basement gets quite cold in the winter, right at about 40 degrees in January. How will that impact operating costs? I'm not sure what the BS period stands for. I mean,
Like
in comparison with, go ahead.
versus
Well, versus. Okay. Um, uh, I think you're still going to be way ahead.
Yeah.
40 degrees, it's at the lower end of what the heat pump likes, but it'll still be cranking along well. And since it starts out with a factor of 3 to 4 in terms of efficiency over the electric resistance, I think you'll still be good. Still be
And
coming up
if it gets
ahead.
to 30, if it gets to 37, the electric resistance will kick in. But a lot will depend upon, again, your usage. If it's only a couple people, even if it went on resistance for a few hours a year, your annual bill wouldn't be adversely affected much.
Okay, Jonathan Kilburn asks, what is the embedded energy in carbon in these units, and how long before they could be carbon neutral if running on 100% renewable clean energy? That's a hard one to
Okay.
unpack. Embedded energy in them, it's going to be a bit more than a regular hot water heater because you've got the compressor and so forth and the extra coil inside. So you can start off a little in the hole in terms of embedded energy, but over the life cycle, it's such a more efficient unit. I think you're going to come out well ahead.
I would agree with that. I'll go another step, which is over time, those products are only going to get, the embedded energy will go down because of nationally, electricity is getting cleaner. 10 years from now, the heat pump water heater is going to be running with on cleaner electricity, whereas gas is just going to continue to be gas. But it's a great, we should be thinking about embedded carbon, but if we're going to do that, we should also think about the methane that's leaked at the drill site and the amount of methane that's leaked as it gets to your house. And when you add those numbers together, you'll be shocked all the experts are saying that oil and gas wells are releasing methane that is it's not being controlled enough, and it's having a much larger factor. Something like 30 or 40% of the global warming, the increase that we've had in the last 20 years has been a result of methane evaporation, not just carbon.
Yeah, I've read that people running the numbers now say that if you take into account all of the gas leaks along the transmission lines and the leaks at the drilling sites and so forth, that actually natural gas ends up very close to or even worse than coal overall. That's shocking. That's completely shocking. But somehow or other, we just hadn't been focused on all the losses, but it's coming to light now. So it's time to move. Lois says, I've heard that 7-foot ceiling height is too low for heat pump water heaters. What have you heard? So 7 feet was always the height. I mean, for 6, 8 years, I've been reading that, and 7-foot ceiling was the minimum that was needed. I'm actually, I have to correct Colette. I have not installed a heat pump water heater yet. I'm in the market, and I put together a big spreadsheet and to help me choose. And the heights vary quite a lot. Some of them are, 6 feet, some are down closer to 4. So, and these are among the standard Ream and Rood and A.O. Smith. So look for ones. If you do have a low ceiling, look for ones that are lower, and I'm sure you can find one that'll work. Okay, this is a good question. The next one. Condos and apartments put the electric heater in small closets, not large enough, with not a large enough air volume to work. Absolutely right. But there are really pretty simple ways to solve that. You really just need airflow from a larger area that will allow the heat pump water heater to function efficiently. So generally, you do two things. You put a louvered door on the closet. Not the whole thing doesn't have to be louvers, but you have to have louvers at one point so that air can come in or go out. And then you put a duct on the heat pump water heater that's either on the input side for the air or the output side for the air, and you pull in air from somewhere else that you want to get rid of it, or you blow it out. So, for example, you're putting out cool air. If you're near the kitchen, and you can dump it into the pantry. If you have a separate pantry, that's great. It keeps everything cooler in there, and it doesn't blow on anybody. Or you put it into some. Anyways, use your imagination. Pull it in or push it out, and then you get enough air volume. So there's a lot of discussion about this. There's a Green Building Advisor has a nice article, a discussion of how to do this. And if I can figure out a way to put a link into that, I'll do so. If somebody comes up with that, has that problem. My plumber here in Western Mass suggested additional air filter to help protect the heat pump water heater's air intake area. For A.L. Smith, there's a hood that one can buy that enables one to add an air filter, or you can do it yourself like I did. So it's a very good point. And I remember the guy's name, but not who he was with. He recommends it. He was an expert in this area, and he recommends a better filter than the standard ones that come, because these are, especially if you're in a dusty area, or and I think this he figured out ways to do it himself, and but there are probably other things out there that you can buy as these become more popular. So yes, an improved filter is not a bad idea. Okay, smartsolarwaterheater.com. Ask Larry about this type of split hot water heater in 2 weeks. Is anyone here familiar? I don't know. Smart solar water heater. Don't know that.
I think that was featured a little bit in the video, or another video that I saw, but I still have not found any good resource on that product. It is eligible for the tax credit. I know that.
Good. Um, Maureen says we already have a Mass Save heat loan for our heat pumps to be installed next month. We didn't include hot water heat pump in the loan. Do you know if we can get a second Mass Save loan to cover the water heat pump? Loie says, I've heard from people who got multiple heat loans. Ask your banker. I believe that's possible to get them. Yeah, I think it didn't used to be, but I believe it is now.
It is, and certainly the limit should be enough as well. But here's the thing: I would ask Mass Save; they'll give you an answer. But here's the way the Inflation Reduction Act tax credits work: you can get multiple tax credits over time, but each time you take the tax credit, it's limited to $2,000. So it's 30% of the cost of the heat pump or the heat pump water heater or solar energy or something like that. So if you were to do a heat pump installation in calendar year 2024, you can get 30% up to $2,000 for that. You would not get the tax credit on the heat pump water heater if you did it in 2024. If you can wait till 2025, you'd be in a situation like I am, where you would get 30% of the cost of the heat pump water heater installation and get the $2,000 tax credit.
Yeah, he was talking earlier about Rewiring America and their calculator. They're a great group and have really done an enormous amount of work to advance all these things. But they ask you to think in terms of the IRA as an IRA. That is a source of well, a financial sort of system. That is the loans that are possible under the IRA in Inflation Reduction Act are many of them renewable year after year after year. So you look at the system and figure out how to use it so you can spread the costs over multiple years and get the maximum amount of rebate. It's a really good system that way. So Belinda says smart solar is under solar hot water program and the tax credit is 30% federal tax credit. So, okay. And then Loie has a link to a video. Oh, that's the one, Matt Reisinger, I believe, the video that that Larry was recommending. Yeah. Okay, and then the last one, I missed this earlier. Heat pump technology is based on the compressor. Could your organization recommend qualified tech to repair failed heat pump compressors? That is the first time I've heard that discussed, and I do not know if if such a person is even around. I did note in the video again that Larry recommended that one of the models has the heat pump as a sort of separate unit on top, and where it can be detached from the tank and replaced, and which is a nice idea. So if it does fail, you don't need to discard your whole heat pump water heater. And as far
So
for repair, I think it's a good idea, but I'm not sure about it yet.
yeah, I have not heard that. What I'd strongly recommend is, whether it's a heat pump or a heat pump water heater, that you get a plumber and maybe an electrician that you really trust. Particularly for the water heater, it's going to be installed by a plumber. The electrician's going to have to come in, but what you should be asking is, are you comfortable with that person? Do they know? You need to have a little conversation with them, like if you need service, are they capable of providing it? They got it at a supply house, they could work backwards to try to get to the manufacturer if there's a problem. Because I don't think that you typically don't hear about the manufacturer sending somebody out to repair it. It would probably have to be somebody else who's in the field doing the installations.
Yeah, and as to getting qualified people, I have a daughter locally who's different than the one I spoke about earlier. She's had a lot of problems with her gas gas furnace water heater, and she's got a really competent guy who's been coming in trying to solve this problem, but she keeps asking him, would you put in a heat pump water heater for us? And he says, no, well, we don't do that. I don't want to do it. If 3 or 4 times she asked me, finally she says, well, maybe I'll try it. Basically, there's a lot of people out there who've had years and years knowing how, installing things they know how to do. And this is completely new, completely foreign, and they tend to be kind of conservative. So either push somebody you trust to try it, or find somebody who's done a lot of them and lean on them. Yeah. So that's the last of the questions that I had.
Are there any further questions this evening? I don't see any hands raised. If not, Larry, I want to thank you very much for joining us again and doing a presentation for us. And Michael, I want to thank you for working with Larry and all the research that you've done. We appreciate all the good information that you put out there. Thank you to everyone in the audience who attended this evening, and we will be sending you a link to the presentation once it's posted on our website. So you're welcome to watch it as many times as you need to catch all the links, because Larry, you put a ton of information in there, and much appreciated. So thank you so much.
Thank you, everybody. Thank you, Michael.
Yeah,
Bye-bye.
thank you, Larry. Great working with you.
Good night.
Good night. Thank you.